Have you ever wondered how a heading indicator works in an airplane? This essential instrument, also known as the directional gyro, is a pilot's best friend when it comes to navigation. The heading indicator provides crucial information about the aircraft's orientation relative to magnetic north, allowing pilots to maintain a steady course throughout their flight. This seemingly simple instrument is, in fact, a marvel of aviation technology. Its functionality is based on the principles of gyroscopic inertia and rigidity in space, which enable it to provide stable and consistent heading information even during turbulent flights. Understanding the heading indicator is vital not just for pilots, but also for aviation enthusiasts who want to gain a comprehensive understanding of navigation in aviation. From the compass rose and relative heading to the heading knob, each part of the heading indicator plays a unique role in ensuring accurate navigation. So, are you ready to explore this intriguing world of headings and bearings? Now that we know what a heading indicator is, let's delve deeper into its components. A heading indicator, like any other sophisticated device, has several parts. Let's delve into the details and get to know these components better. First, we have the compass rose. This is a circular scale that's graduated in degrees, and it's used to represent the aircraft's direction relative to magnetic north. Next, we have the relative heading. This is the direction in which the aircraft is moving relative to its nose. Then we have the heading knob. This is used to align the indicator with the aircraft's magnetic compass. Finally, reading the indicator. The heading is read from the top of the indicator, where a lubber line, a fixed reference line, is located. The number under the lubber line shows the aircraft's current heading in degrees. Understanding the parts is just the start. Now, we move on to how this fascinating device works. The heading indicator, though small, performs a significant role in an airplane. This crucial instrument provides pilots with the aircraft's orientation relative to magnetic north, a cornerstone of navigation. The heading indicator operates on the principles of rigidity in space and precession, fundamental concepts in gyroscopic physics. At the heart of the heading indicator is a spinning gyroscope. This gyroscope's rigidity in space allows it to maintain an orientation regardless of the aircraft's movements. In other words, the gyroscope's axis remains fixed, and the aircraft rotates around it. This property is what allows the heading indicator to accurately depict the aircraft's heading. Precession, on the other hand, is the force that causes the gyroscope to drift from its original orientation over time. This drift, known as gyroscopic apparent wander, is corrected by the heading knob. The heading indicator interacts seamlessly with other aircraft systems. It feeds into the autopilot system, providing vital information to maintain the aircraft's desired course. The compass rose, a circular scale around the periphery of the heading indicator, aligns with the aircraft's longitudinal axis and provides an immediate visual representation of the aircraft's heading. However, like all things, the heading indicator also has its limitations. It is subject to errors, including real wander, due to Earth's rotation and the aircraft's movement over its surface. Additionally, it requires regular adjustments to correct for these errors and maintain accuracy. But more on that in the next scene. No device is perfect, and the heading indicator is no exception. Let's delve into the limitations of this essential instrument. The heading indicator, while highly accurate, is subject to errors known as gyroscopic apparent wander and real wander. Gyroscopic apparent wander refers to the slight drift in the heading indicator caused by Earth's rotation. This phenomenon can result in a discrepancy of up to 15 degrees every hour. Now, that's quite a bit off course if you're not paying attention. Then we have real wander, which is a mechanical error within the gyro itself. Factors like friction, temperature changes, or even power supply variations can lead to this kind of wander, but don't let these limitations deter you. The heading indicator is still an invaluable tool in the cockpit, providing crucial navigation data to pilots. Despite these limitations, there are ways to adjust the heading indicator to ensure it functions accurately. Up next, we'll explore how these adjustments are made. Stay tuned. A well-adjusted heading indicator is a pilot's best friend. Now let's discuss how you can adjust the heading indicator. This process isn't as daunting as it might seem, but it does require precision and attention to detail. So buckle up and let's fly into it. The first step involves aligning the heading indicator with the magnetic compass. It's best to do this when the aircraft is stationary to avoid any gyroscopic errors. The magnetic compass serves as your primary reference here, so always ensure it's in good working condition. Next, rotate the heading knob until the heading indicator matches the magnetic compass. It's crucial to remember that the heading indicator shows the aircraft's direction relative to magnetic north, not true north. Therefore, always cross-check with the magnetic compass. Now, you might wonder what happens during long flights. Well, the heading indicator is not perfect. It's prone to something called gyroscopic precession, which can cause it to drift from the actual heading. This drift is usually slow, but over time, it can become significant. To counter this, pilots must periodically adjust their heading indicator during flight. This adjustment is typically done every 15 minutes, but it may vary depending on the aircraft and conditions. It's a simple yet crucial step that ensures you're always on the right track. Remember, a well-adjusted heading indicator can make the difference between a smooth flight and one that's, well, not so smooth. With the heading indicator adjusted, it's time to explore a related device, the gyromagnetic compass. The gyromagnetic compass is another crucial navigational tool in aviation. This little marvel of technology is all about helping pilots navigate their way through the skies. So, what's the secret behind it? It's all in the name, gyromagnetic. The compass combines the principles of a gyroscope and magnetism to provide accurate heading information. The gyromagnetic compass, unlike the traditional magnetic compass, is not affected by the aircraft's pitch or roll. It remains steady, providing a reliable reference for the pilot. This is where the gyroscope comes into play, a spinning wheel that maintains its orientation due to the principle of angular momentum. The magnetic part of the compass comes into play when it aligns itself with the Earth's magnetic field. This interaction allows the compass to point towards the magnetic north. The gyromagnetic compass then communicates this information to the heading indicator, which displays the aircraft's heading in relation to the magnetic north. But remember, the gyromagnetic compass isn't a standalone tool. It works in harmony with the heading indicator, each compensating for the other's limitations. For instance, the heading indicator is prone to drift due to gyroscopic precession, which the gyromagnetic compass corrects periodically. Understanding these devices not only enhances your knowledge of aviation, but also heightens your appreciation for the complexity of flying. So isn't it fascinating how a small device like a heading indicator plays such a big role in flying an airplane? Truly, the marvels of aviation technology never cease to amaze. From our journey today, we've learned that this compact yet complex device is a crucial part of any aircraft's navigation system. It's much more than a compass rose and a heading knob. It's a finely tuned instrument that helps pilots navigate the skies with precision. We delved into the inner workings of a heading indicator, understanding how it uses the principles of gyroscopes to pinpoint the aircraft's direction. We also examined how to read the indicator accurately, a critical skill for any aviator. However, just like any other piece of technology, it has its limitations. We discussed the phenomena of gyroscopic apparent wander and real wander, both of which can impact the accuracy of the heading indicator. But we also learned how adjustments can be made to mitigate these issues. Finally, we explored the world of the gyromagnetic compass, a complementary navigation tool that works hand in hand with the heading indicator, giving pilots a comprehensive view of their heading. Through all of this, it's clear to see that the heading indicator is a shining example of human ingenuity and the relentless pursuit of progress. Remember, the sky is not the limit, it's just the beginning. Stay curious and keep exploring the wonders of aviation.